Good morning, good afternoon, and good evening, depending on where you are and the time you are accessing the video. It's back to our normal classes for Physics 102, and the topic for today is electricity and magnetism. The title of today's the Physics 102 is electricity and magnetism, while our course for today is electric force and field. Electric force and field. What is Coulomb's law? Because that is the target for today's lesson. And what is electric field? Coulomb's law, from the general definition and from what Coulomb has stated and what we know, Coulomb's law states that the force of attraction between two charges is directly proportional to the charges and inversely proportional to the square of their distances apart. This simply means that F is equal to K, which is introduced when the proportionality sign was removed, then Q1, one of the charge, Q2 the second charge, and divided by the square of their distances. R is represent the square of the distances and is squared. So Coulomb simply states this, and it's represented mathematically with this formula. So for an electric field is said to exist at a point in space if a charged particle placed at that point experiences a force that will not be felt by an uncharged particle. Remember, I said electric field. Then what if we just said a field, not electric field? Field is just a region in space. You see the difference between field and electric field? Field is just a region in space, while electric field is a region where charged particles experiences a force. So in a field, no experience of force, it's just a field. That's the difference, simple difference between the two. Now let us look at the relationship between a charge, the force, and electric field. So when there is a charge in an electric field, there is going to be a force, and for such reason there is going to be a relationship between the three, which states that force is equal to charge times electric field, and thereby you can now show that electric field is forced by unit charge. And what are field lines? Field lines are continuous directed lines drawn so that at any point on the line, the direction of the line shows the direction of the field. And the static field line starts on positive charge surfaces and on negative charge. And this is what is shown. Field lines for isolated charge, field lines for two unlike charges. When you have a positive and a negative charge brought close together, the flux line flows out from the positive to the negative charge. So you see the direction of flow. This line is what we call the density of flux. And for a single point charge, if it's a positive charge, the line goes out of the positive charge. So test your knowledge by drawing for two like charges. For a point charge, this is what it looks like. For an isolated negative charge, and this is what it looks like. As I was earlier explaining, I said the density for field lines gives the strength of the field. The higher the number of field lines, the greater the strength of the field. The arrow just gives you the direction. And this is calculation based on what we have explained. You can find out that we mentioned earlier that electric field is force divided by charge, and where is equal to KQQ1 over R squared. Put the formula for F, put the formula for Q. If you calculate and go further, you end up having a KQ divided by R squared. So there's electric field for a single point charge. That's an example given. The point charge is this is the value, and the negative, the distance between the charge and the field is this, given by this. For you to solve the example, electric field is force KQ1 all over R squared. So the K is a constant called 9 times 10 to the power 10, and then the charge of the value of the charge 1.7 minus 19 divided by the distance apart. The distance is 1 times 10 minus 10, and this gives you the value of that. Same with this example here, asked to find the force of attraction between two charges. This is one of the charge, and this is the second charge. Just input the values to the formula, do the calculations, and then you end up having this. The next question is same, but anyway a little bit technical, because here they are saying there are 26 protons. The proton and electrons are the same, rather the proton is positive and electron is negative, and all of them have the same value, 1.6 times minus 19. One is positive, one is negative, but the proton is 26, so it means you are multiplying 1.6 times 26 for Q1, and for Q2 is just 1. And when you do all the multiplication, put in the values and divide by their distance apart, which is this, and you get that value. Same with number 3, it's the same issue. They say two groups of 3 protons each are located at 2 opposite corners. So one is at this end and the other is at this end. There are 3 protons here, there are 3 protons here. And remember the value of charge is 1.6 times 10 to the power minus 19. So it's 3 times 1 point. And at the other point you repeat the same calculation and then divide by the distance apart. However, the distance is in 10 centimeter. You need to convert the distance to meter. And the conversion for 10 centimeter to meter is 10 divided by 100. And whatever you get is going to give you what? It gives you the meter. Let me repeat that again. To convert the radius is given in centimeter, and if you want to convert the radius to meter, because the radius is just 10 cm, you need to divide that 10 cm by 100 to give you a meter. So 10 divided by 100 will give you 0.1 meter. So the radius is 0.1 meter, so you divide that value by 0.1 meter, and then voila, you've gotten your answer. The fourth question is how far apart you're asking to find. So make also your formula from Coulomb's law and then input all the values you're going to get R. And then the last question is for you to find the second value of Q2. That you can do following the procedures listed. So what is the difference between electric force and field, which I've stated is just for a recap. Electric force is a force felt by a charge at some location, while electric field is the region where a force is experienced when a charge is placed. Both of them are vectors. Both are vectors and they have both magnitude and direction. Thank you for listening to this lecture. If there are questions, please post your questions on our link and answers will be made available. Thank you very much and goodbye.